Hi, this is the YouTube channel for Math Contest Go Go Go. What I want to do for this channel is to build a platform for math lovers in order to make them discuss about different kinds of math problems. I will update a video about challenging problems every day. If you would like, please subscribe below. Hi, today we are going to talk about a new logarithm in the, what's that called? We are going to talk about a new algorithm which is called depth first search or DFS. So it is like you just keep searching a tree, binary tree, which it should be looks like this. Oh, that line doesn't count, I mean. So what you achieve in this search is that you search every plot based on the depths first, with the depths as a priority. So I'm going to model how this will look like. So in this case, after some times of search, it will check whether, whether a certain thing you want to find is achieved or not. So in this case, some simple problem regarding this is like the maze, the number printing problems, which I will discuss in the next week, and so on. So it is just the basic idea of DFX. So we are now going to talk about how this code will approximately look like. So it will have a main function, which is public static void main. Just I don't want to type. Which is public static void main string arg. It will serve as its basic function, which it will usually have a, if you, what's that called? You won't really have a mean, but it will have a book function. So which in this case, it will record your procedure, which it usually runs in the form of Boolean, which is true or false, or 0 and 1, 0 or 1. So, and in this case, it will lead you to the second function, which is the DFS function, which in there it will usually have at least one candidate of something we don't know. And in that in that function, if we call it success or not, so it will be DFS in something, and in the code, it will usually have a, always have a checker. Like, if you get success, then you just break. It will have a recording process. If it's not success, and it will go up to the DFS. It is a bit like recursion, actually. Just as I say. So in this else case, it will have like book is 0 and then book goes to 1 again. Yes. So in this case, it is just how this code approximately look like. And it will always have a recursive function back here. So now we are going to talk about a problem that will help us know better about the depth first search. So in this case, this problem, why I make this problem, actually it's not I make this problem, it's just I think a way of making a new problem in an easy way without, thinking about just copying the old problem directly. This code is based on CTC, which is Canadian Computer Challenge Junior 2010 Junior 5. Yes, and it also based on the traditional maze problem, which I think every person who learned depth first search, it is the first code of every person who learned depth first search. So it is a code. Given a maze, length of m times n. Don't ask me what's the value of m and n. So it will have, so we just represent 0 as the place you can go and 1 as the obstacle which you can't step on. It is a maze. So in this code, you are going to give a starting point, which is located at AB, where A is less than M and B is less than N. And you are going to give an end point where C and D are also less than M and N. So your objective is to locate where the, not locate, it is the way, so your objective is to determine the shortest path you can get. So in this case, the shortest path is going to be 1, 2, 3, 4, 5, 6, 7, which the 7 is 1, row 1, column 1, row 2, column 1, row 3, column 1, row 3, column 2, row 3, column 3, row 3, column 4, row 4, column 4. So this is just your goal. You can just think this problem as thinking in a binary tree. You can just think like go there, go there, go there, go this way, go that way, go this way, go that way. Yes. So, to do this code, we have set up so you can see that the basic structure is well shown in this code. So to do this, let's just model how this code actually will activate throughout the entire code. So in the beginning, it will have a scanner, which is scan. So the use of scanner in this case is to enter the number. So we set the I, and so you can actually see there's actually those codes there. So which N is represent the starting point. No, N is represent the, what's that called? The length, and M is representing the width. Index is representing the, what's that called? And X is representing the final point, and Y is also representing the final Y point, because it is a XY, it is a XY thing. And it will have a less, which is the minimum step. Just a quick note, why we prefer to choose MINN in the code instead of MIN. Because MIN in computer, it have a special meaning. Even though until now I still don't know what the special meaning MIN of in the Java represents. Okay. So it is, we call this less. A static int A, which is the entire A array, it is representing the whole length, entire grid, entire maze. And the book is respectively to A array. So it is like you book 0 or 1 to record whether you have walk pass or not in the code. Okay, so we do a scan. Easy scan. So in this case, I and J, don't worry, they are just serve us 2, 4. You can actually like convert this into ij into int I, int j. And n and m are representing the length and width. On this case, begin x and begin y represent the starting point. So which means it is the starting point, it will locate here. And I'm going to explain why I choose not to use static in the end x, in the begin x and begin y. And use the static in end x and end y, because if you find the entire code, begin x and begin y will only serve the function of locate the starting point, and after that they don't actually have the use. So it is how begin x and begin y will work. And in this case, we just set the initial point, which is starting point, into 1. Book, begin x, begin y. It is a 1. So 1 means it is already walked by in the book. And 1 in the, what's that called? A is a location that you have already passed. Like it is an obstacle. So after the depth first search, it is a depth first search here. So it will serve as candidates. So begin x, begin y, 0 are just candidates. Okay, so after that we just print out the shortest path. So in this code, it will go up to here. So now we are going to explain. In this case, int step means the candidates, means the current step it is working, so which it will change and update it with the less. And x and y means it should means the current x point and y point he's currently on. So we first define occur step. Occur step is representing all the way you have walked to. According to the rule of night, as I haven't said, it is based on night hop, and all the walking procedure is that you should walk by the way of night hop like this. So we have generated 8 ways of calculating. 8. So we can actually explain, which in the first way it is going up 1 and going right 2. You all know what's the way of walking the night. The second way is going 1 and going left for 2, which is -2. The second is going up for 2 grids and going right for 1 grid. The third is going up for 2 grid and going left for 1 grid. The fifth is going left for 1 grid and going down. Going down for 1 grid and going right for 2 grid. Going down for 1 grid and going left for -2 grid. Going down 2 grid and going 1 grid left, and going down 2 grid and going 1 grid left. Yes. 8 ways. Okay, so we are going to talk about the rest of the code for tomorrow, which is the next code. See you. In fact, problems, they have many solutions, and my solution is only a part of them. If you have more challenging solutions, please comment below. And don't forget, I will also post my problems there. See you tomorrow!